So to solve the problem in graphical method, we have come on to a new page. And as you can see the question here and also the earlier figure describing the motion of this train in three parts. AC was accelerated motion, CD was constant velocity motion, and DB was decelerated motion. All the symbols explained also are written here for quick reference, and we have got it from this question. Maximum speed attained by the train is 27.5 meters per second. Over the first part of motion AC, acceleration A1 is 0.4 meters per second square. Last part of motion DB, deceleration was 0.6 meters per second square, and the distance between the two stations is 5,000 meters. So we shall plot the motion of this train now in a velocity versus time graph. And for that I choose two axes. The horizontal axis is the t-axis and the vertical axis is the velocity v-axis. And the graph should look like this, as shown by this green one, made up of three parts as expected. The first part, OP, a straight line, represents constant acceleration motion from A to C. The horizontal part, PQ, represents constant velocity motion from C to D. And the straight line part, QR, sloping downwards, represents decelerated motion from D to B. To complete my construction, let me draw two perpendiculars from the points P and Q onto the time axis, and also draw a dashed line as shown from this point P onto this velocity axis. Let me call these points S and T. It is obvious that this point on the v-axis represents the maximum speed attained by the train, that is Vmax, 27.5 meters per second. And the length OS represents the time taken T1 for the accelerated part of the travel. Similarly, ST represents the time T3 taken for the constant velocity motion, and TR represents the time T2 taken for the decelerated motion from D to B. I'll also take this angle to be θ1 and this angle to be θ2, and want to remind you that any velocity versus time graph, the slope of the graph represents acceleration and the area under the graph represents the displacement over a given duration of the trip. So keeping this in mind, let me consider now the accelerated part of the motion, that is represented by AC in the above diagram as shown graphically by this part OP, right? So here we understand in the triangle OPS, a right angle triangle, the slope of the portion OP, that is tan θ1, is giving the acceleration A1, that is 0.400 meter per second square. And since tan θ1 in triangle OPS is given by the perpendicular, that is PS divided by the base OS, we get from here that OS is given by PS divided by tan θ1, right? But then OS is nothing but the time of travel T1 for the accelerated part. So I can write down the time of travel of accelerated part T1, that is OS, is coming out to be PS, which is equal to Vmax divided by tan θ1, that is A1, 27.5 meter per second divided by 0.400 meter per second square. Make the calculation and show that OS represents graphically a time of 68.8 seconds. And once we have got that, we can find out the displacement by the train during this part of motion AC, given by the area under the graph OP, that is the area of the triangle OPS. So I might write down that the displacement that is called x1, as you know, this is given by area of triangle OPS, which is half into height, that is PS, into base, that is OS. This is coming out to be half. PS is equal to V max, and OS just now found to be T1, that is, I'm calling it T1 only, putting the values, that is half into 27.5 meter per second into T1 was found to be 68.8 second. Complete the calculation to show that the area delta OPS is coming out to be 946 meters, and therefore my conclusion is that the displacement over the part AC x1 is 946 meters. This is 946 meters. Let us now consider the last part of motion, that is dB, which is the decelerated part of motion, represented by the part, the straight line QR in this V versus T graph. And if this angle is taken to be theta 2, you understand the other side, this angle is supplementary angle, that is pi minus theta 2. And the slope of this straight line QR is given by tan of this angle, that is tan of pi minus theta 2. You should always remember, slope of a line is found by taking the tangent of the angle measured from the positive axis anti-clockwise towards that line. Therefore, I might write down here that the slope of QR, which is tan pi minus theta 2, this is given to be A2. As you can see, noted down, the value of A2 is minus 0.600 meter per second square. But then tan 180 minus theta 2, that is minus tan theta 2, and we have here tan theta 2 is coming out to be plus 0.600 meter per second square. In my figure, that is tan theta 2 is modulus value of A2, that's a positive quantity. Now, keeping this in mind, we also note that in this right angle triangle QTR, we might write down that tan theta 2 is perpendicular QT divided by the base, that is TR, and therefore I am getting from here that the length TR, which you understand represents T2, the time of travel from D to B, decelerated motion. So I'm finding out this TR. TR is coming out to be QT divided by tan theta 2. But QT is nothing but V max. So it is V max divided by tan theta 2. That is the modulus value of the acceleration A2. Putting the values now 27.5 meter per second. Modulus of A2 just now noted to be 0.600 meter per second square. Complete the calculation to show that this TR represents a time of 45.8 seconds. Remember, this TR is equal to T2, that explained to be the time of travel from D to B.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams.
Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.